Hi dear, today we'll start with the chapter 10 light, reflection and refraction. Okay, so what is mean by light? We are studied in the lower classes, right? What is mean by light? Light is a form of energy which enables us to see things around us, right? We are able to see things around us because only because of light. Okay, you know that light travels along a straight path, right? And the speed of the light can also be measured, right? uh, the Actually it is a constant value, universal constant. Wherever the light travels, it travels with the same speed. Okay, so that is your constant speed. That constant speed is denoted by, that light speed is denoted by small c, which is equals to 3 into 10 to the power of 8 meter per second. Per second it will travel 3 into 10 to the power of 8 meters. Okay, so it is a universal constant. It is denoted by small c as light speed, 3 into 10 to the power of 8 meter per seconds. Okay, that's all about this light. This we have studied in the lower class itself. Light is a form of energy which enables us to see things around us. It travels in the straight path, and light speed of the light is equals to 3 into 10 to the power of 8 meter per seconds. Okay, okay. What makes things visible to us? Whenever we are standing in a dark room, we are not able to see things. Once we switch on the light, we are able to see things. How it is visible to our eyes? How it is visible? So if a light falls on the object, once it strikes the object will start reflecting, right? This reflected light when received by eyes enables us to see things. Okay, an object reflects light that falls on it. This reflected light when received by our eyes enable us to see things. Okay, next, we always thought that light travels in a straight path. Okay, but some other light can also behave as a wave and also as a particle. Okay, it is not only behave as a ray. Ray means what? Travels along a straight path. Travels along a straight path, right? But it behave as a wave also. It behave as a small particle, stream of particles also. Wave means whenever it passes through the obstacle, when there is a bend, it will also bend, right? So it will behave as a wave and it will behave as a particles also. Okay, but here in this layer we are going to consider the nature of the light only as a ray. That means it travels along a straight path only. Okay, we are not going to consider it as a wave or particle. These you will study in your higher classes. Okay, light as a wave, light as a particles. Okay, so in this layer we are going to learn the nature of the light only as a ray. A ray means it travels along a straight path, right? Next, so next one is reflection of light. What does mean by reflection? That is bouncing back of ray of light when it strikes a boundary between different media through which it cannot pass. Bouncing back means what? If it is not, for example, a wall is there. If you kick a football, it will strike the wall. Since it is not able to pass through the wall, so it bounces back. It strike the wall and it bounces back like this, right? So a boundary is there, a medium is there. Okay, this is your reflection. Okay, likewise light will also be like that. It will strike the boundary or some medium and it will be reflected back when it is not able to pass through this medium. Okay, when it is not able to pass through this medium, it will reflect it back. This is a reflection of light. Bouncing back of ray of light when it strikes a boundary between different media through which it cannot pass. Okay, so we'll see some terminologies related with the reflection of light. Incident ray, normal, reflected. Okay, and Angle of incidence, angle of reflection. Okay. What is meant by incident ray? The ray which strikes the mirror. The ray which strikes the. Usually we will see the images in a most polished thing, that is your mirror. It is a polished thing, mirror. So we here the your medium or your boundary is your mirror. The light strikes the mirror. The light which strikes the mirror is called incident ray. Okay, the ray of light which strikes the mirror is called incident ray, and the ray which is reflected, bounce back, no, this is called reflected ray. What is that? Reflected ray. The ray of light which bounce back from the mirror is called reflected ray. Okay. What is this normal? Normal, this is an imaginary line. Okay. For these purposes, for calculation purposes and all, we are imagine. It is an imaginary line. Okay. It is an imaginary line which is drawn perpendicular to the boundary. Perpendicular, that is to 90 degree to the boundary. This is plane mirror, and this normal is perpendicular to that, 90 degree to that. Okay. Normal is an imaginary line which is drawn perpendicular to the plane of the boundary. Next, angle of incidence. What is angle of incidence? The angle between the incident ray and the normal is called angle of incidence, right? And the angle between the reflected ray and the normal is called angle of reflection, right? Angle of incidence. The angle which the incident ray makes with the normal is known as angle of incidence. Angle of reflection. The angle which the reflected rays make with the normal is known as angle of reflection. Okay. These are the terminologies related with the reflection of lights. Okay. We'll see the laws of reflection of light. So there are two laws of reflections of lights are there. First law is the angle of incidence is equal to the angle of reflection. So always this angle of incidence, this I is know that it is denoted by small I. I is the angle of incidence is always equal to the angle of reflection. This is equals to small r. I have written r equals to theta, I equals to theta. That means these both the angles are same. Okay. Whatever angle it may strike, at whatever angle, for example, this is your medium or boundary. If the incident ray strike like this, it will be reflected back. Your imaginary line normal is this angle is equals to this angle. Both are same. Okay. Even if it strikes like this, it will be reflected back like this. So your this angle and this angle are equal. Always the angle of incidence is equals to the angle of reflection. This is the first law of reflection. Next, the incident ray, the normal to the mirror of mirror at the point of incidence, and the reflected ray. That means incident ray, reflected ray, normal all lie on the same plane. So if you look at this, see, it is all lie on the same plane. See, it is look at this. All lie on the same plane. Okay. So these are the laws of reflection of light. Okay. What are the two laws of reflection of light? Angle of incidence is always equal to the angle of reflection. The incident ray, normal, and the reflected ray all lie on the same plane. Okay. Next we'll see how the image looks in a plane mirror. Okay. That means the properties of the image formed by a plane mirror. I use the word plane mirror here. Okay. So in day-to-day life we will see, no, that's plane mirror. Okay. The image formed is always virtual, not real. That means what? Once the light incident on this, it is reflected back, right? So it is not passing through the mirror, correct? This is your mirror. It is not passing through the mirror. Once it is reflected back, see, it will be reflecting back like this, right? So we are up here. We thought that the lines appears to image, but it is not actually converge, right? These we are think that it appears to image and the image is formed here, right? Image is formed here. So it is not a real one, it is an virtual one. Okay, so the image formed is always virtual, it is not real. Okay, because the light will not pass through this mirror, it will be reflected by, and we are extending these lines, and we are telling that it is converging here and your image will appear here. Okay, so it is not a real image, it is a virtual one. The image formed is always erect. If you are standing like this, your image will be upright only, it will be like this only. Okay, it will not upside down, it will be erect. And size of the image is equals to size of the object. Whoever is standing in front of the mirror, the same size will be reflected, right? For example, the image is like this, means here the images will be like this. Okay, it will not be diminished or it will not be magnified. The size of the image is always equal to the size of the object. Next one, the distance of the object from the mirror is equal to the distance of the image from the mirror. That means what? This is a mirror. If you are standing here, means, so the distance between the object from the mirror, this is the object, you are standing here, the distance is, for example, d centimeter means, and the image formed also will be d centimeter, it will be here. Okay, the distance of the object from the mirror is equal to the distance of the image from the mirror. Okay, for example, if you are standing here, means your image will be formed here. These two distances are equal. Okay, always equal. Next one, image formed is laterally inverted. If you are standing in front of the mirror, you can see your right side always be seen in the left side, and left side part will be seen in the right side, right? That is a laterally inverted image. That means left and right reversal of the image formed on the mirror when compared with the object, right? If you raise your left hand, means in the mirror you can see your right hand has been right side hand has been raised, right? So that is called laterally inverted. That is left and right reversal of the image. That is called laterally inverted image. Okay. So what are the properties of the image formed by the plane mirror? It is virtual, it is erect, it is laterally inverted, and the size of the image is equals to size of the object, and the distance of the object from the mirror is equals to the distance of the image from the mirror. So these are the 5 main properties of the images formed by a plane mirror. Okay, laterally inverted means left and right reversal of the image. Okay, thank you.